Okay, so of course we knew that you had this tough tough deadlines, but it was important for you to have a notion of these two problem sets before May, because then I will ask you which problem sets are the most problematic for you. And if you don't have the time to review this, it would be difficult to include this in the revision session and for you to have a clear idea of what is happening in this module. So it's of course it will be recorded, so even for tomorrow we'll have the same room, so it will be recorded too. And let's say hello to everyone will watch us later on during the month. Okay, so first of all, I would like you to describe me what do we mean by liability. Any let's say, what is the dynamic involved in liability and how can you define liability in itself?
The potential costs you could be held to in the event you impose an externality on somebody else?
Yes. But this depends on the kind of liability, right? So if we need to, like, in 2 words, what is liability? This is something that you can use in the exam, so that's why I'm asking. Is it an economic instrument? Can we define it as economic instrument?
It's not a legal instrument.
It's a legal instrument, right? So it's a legal instrument that allows us to pay back the...
To take into account the risk of our action.
Yes, and exactly. And so taking into account also the externalities, the negative externalities that some agents might produce in our society. Yeah? Of course, we can distinguish between different kinds of liabilities, and we'll see this later on. Okay, so again, in this case, we have a firm, then we have the victims, and then we have like a regulator, which is setting up the liability. Yeah? So first of all, in this case, we have we can define 2 functions, which are function of the level of precaution. Yeah? So the firm can take a different level of precaution, yeah? And these precautionary actions will have a cost and will impact the expected damage of the activity this firm is actually doing. Yeah? So as you can see, of course, the cost will increase. The expected damage are expected to decrease. Yeah? Because you put more level of precaution and the expected damage is going down. How much down? Well, usually there is always a risk of damage, right? In this problem set, for the sake of our calculation and to make it easier to derive, we set up a maximum amount of precaution equals to 12. In this case, as you can see, if we plug 12, 12, 12, the expected damage will be 0. Yeah? So we don't have an expected damage which is going towards an asymptote, but it will decrease until 0. Yeah? I think I will move there. No, I will stay here, but sometimes I will go there because they are recording that screen there. So sometimes I will show things also there just for the other ones. Okay, can you see well? The lights are okay? A bit more maybe? Yeah. It seems that they are full. Probably it's the screen, this one. Yes. Better? No. Too much. 4. Perfect. Sit down. This is more natural, right? Okay. So, we have the two functions, one for cost and one for the expected damage. Yeah? In this problem set, we assume a strict liability. Yeah? So far, for the first initial points. Yeah? So this means that if something happens, the firm will pay. Yeah? Okay. So first of all, we need to graph these two functions. Yeah? Cost of precaution and expected damages. In the same point, we are also requiring you to graph the total cost function. Yeah? In this case, the total cost function is the sum of the cost of precaution and the expected damages. Yeah? Why is that? Because we have strict liability. Yeah? So, according to the firm, the total cost will be what I'm spending in precaution and the expected damage that I will need to pay to the victims. Okay? And I need to take this into account, of course. Okay, let's see point A and then we'll scroll up again. Okay, so here we are saying that we already have the two functions and we need to find out the third one, right? So, as you can see, we will sum up the cost function plus the estimated, the expected damage. Yeah. In this way, you can find out the total cost. How can we graph this? Well, the most convenient thing to do. Yes. Yes.
Why is the expected damage always negative?
That's a good question.
Using your total cost.
Yes. So here.
It goes like a negative sign.
Sorry.
Should it be negative? Because the expected damage there is going to be a negative value.
Well, if you put one here, and one here, it should be a positive value, no? Because this is to the power of 3. Yeah. So let's see the graph together. So this is the expected damage. Yeah. So you see that it will converge to 0 at some point, and well, it's easy to depict it like this, but we can assume here to have an asymptote, right?
So a really basic question: what technique would you use to graph that in an exam?
Yes, that's
It's quite. I mean, it's a 3-part cubic equation.
Yes, that's true. Well, I'm not the module leader here, but from my side, I think that if we have these two equations, you can expect this to have this behavior, yeah, because it's to the power of 3, yeah. For this one instead, you can find out. I'm quite sure that if we don't put asymptote here, you will not have an asymptote for the expected damages. So I would find the point in which it goes to 0. So if there is a maximum level of precaution, you know that this point is the one in which the expected damage will convert to, and will finish there because it will be 0. Given that you need to calculate later on the equilibrium point, let's say, with the marginal values, of course, even if this point is here or here, so if it's 4 or 8, you will not lose points. Yeah. So try to think about how the function is and which kind of strategical points you can find out, and you can draw something similar. Of course, no one expects you to spend more than I don't know, 5 minutes, 10 minutes to draw this because you don't have the time. Of course, in a problem set you can study the function, but maybe for that you need too much time, I think. Okay. Okay, so for the total cost, the easiest way is just to consider these two functions and draw something that considers the two. Here we are summing up vertically, yeah, as we were doing in the initial problem sets, yeah, with the market demand. Okay, so we have done this, so we can look part B. In part B, we need to compute and graph the marginal cost of precaution and the negative marginal expected damage. Okay, first of all, what is the negative marginal expected damage? Because of course, if you look at the graph, it's very convenient to have a negative marginal expected damage, because in this way we can find the point in which the two marginals intersect, right? But what is the economic reasoning of doing the negative marginal expected damage? Well, in this case, it will be the benefit of the precaution, yeah? So the additional the additional level of precaution, let's say that will increase the benefit for the population, right? So instead of looking at the marginal expected damage, we look at the negative, yeah? So instead of having a benefit, a damage, we look at the benefit, which is which derives from the fact that we are increasing the level of precaution. Yeah. I think you have something about this in the slides, but if you are struggling in this concept, of course, let me know.
And just a very quick reminder that the marginal equation is the first derivative.
Yes. How can we find those two equations? We have the cost function and the expected damage function. Both of them are function of the precaution, right? So we do the first derivative with respect to x. Yeah. In this case, we use the power rule, so we take down the 3. We have x to the power of 2 plus 4x plus 3. In this case, we do the same, right? So here we have the 3, we take it down. The derivative of x is 1. Yeah. So it's 3 times 1, open bracket, and the function to the power of n minus 1. So it was 3, so now it's 2. Yeah? We do the same here, and here we can do the same here. Yeah? So here it was at the power of 1, minus 1, it will be to the power of 0, so the parenthesis goes away. Yeah? Let's see again 1 second the second equation. Yeah? So this is the second equation, right? So if we lower this level, the level of this, the power of this one from 1 to 0, this goes to 1. So the derivative of this is 2 times 1 times 1. Yeah, because the derivative of this is 1. Here we put the 2 here. And then we have 2 times the derivative of x, which is 1. Yeah, so 2, and then times 1 times this one to the power of n minus 1. So 2 minus 1. 1. Yeah? Okay. Let's try to do the same with this one. We take the 3 here, the derivative of x is still 1, so 3 times 1, and then we have this one to the power of 3 minus 1, which is 2. Okay?
Right. Do you want to just write that on the board?
Let's try to write. Let's do like this. Expected damage is minus x minus 12 to the power of 3 minus x minus 12 to the power of 2 minus x minus 12 2. Okay. Okay. So let's try to take the derivative of this, yeah? Derivative of AD with respect to x, yeah? So let's try to do the first one. So minus or plus? Minus. Then I bring this one down. Yes? So 3. Then the derivative of what is inside here. The derivative of x then. What is the derivative of x? 1. 1 times 1 times. Now we put all the function x minus 12, 3 minus 1. Yeah? And this is 2. Okay? Okay, tell me the second one. Okay. 2 times 1 times x minus 12. Yeah? And then it will be 2 minus 1, which is 1. Yeah? Here we have minus 2 times 1, yeah, times x minus 12 to the power of 0. Yeah? This is 1. This is equal to 1. Yeah? And so we can cancel this, and we can write 1. Yeah? And so this is a minus 2. Okay? The other one is exactly the same, but it's easier, right? So 3x to the power of 2, 4x plus 3, and this one is cancelled out. Yeah? Okay, we are still applying the power rule. Okay, so in this way, with the first derivative, we find out our two values here. Yeah? Given that it's the minus marginal expected damage, we change the signs. Yeah? So we don't have all those minus now. Yes?
Why are we looking at the negative?
We are looking at the negative because we want to find the point in which they cross. Yeah? From another point of view, in this way we are looking at the marginal expected benefit. Yeah? Because we are paying some precaution. Yeah? So it has an economic reason. It's also very convenient for us because in this way we have the specular, yeah, on the axis, of the same axis. Yes?
I don't know if I understood well, but so the negative marginal expected damage is the marginal expected benefit?
From the precaution that we are applying. Yeah?
Only to the equal point or generally? Only to the equilibrium point? Or?
No, generally. So this specular function can be defined as marginal expected benefit. Yeah? The marginal cost curve is exactly like we expect, right?
Okay, so it's
Yes.
the same as if you do the first certain condition as the total costs.
Well, in that case, you are addressing point 3, I think. Point C.
But if you, because you will have both marginal
Yes.
and marginal cost and marginal expected damage.
Yes.
That will change the,
No,
because it's the first condition is equal 0, so that will be negative marginal.
No, yes. The concept is the same.
Okay.
Of course, you can do that when you are equating the two, right? So in point C, when you are trying to because in the in point C, let's see point C 1 second, just a question to see what we are doing here. So we have found we have graphed the functions. We have computed the two marginals, so marginal cost of precaution and marginal expected damages. Now we need to compute the optimal level of precaution. Yeah? How can you do that? One way is to equate the marginal cost of precaution and the marginal expected damage. Yeah?
The negative.
Then yes, so because you put on the other side, right? The other way is to minimize the total cost of the firm. How can you do that? You take the total cost of the firm and you do the partial derivative with respect to x. Okay? The two of them will bring the same outcome. Yeah? So let's try to see this together. Okay. So, how to compute the optimal level of precaution for the firm? We can minimize the total cost, so the sum of the cost of the two, so cost of a precaution and expected damage, or we can equate the marginal cost of precaution and the negative marginal expected damage. Yeah, so the marginal expected benefit. Yeah, we have these two from before, so it's very easy to just put them equal, right? Okay, here we are just equating the two, right? So we equate, you see that, yeah, from here you need to get here. How do you do that? Well, the only calculation you need to do, you need to multiply those, right? So you have that part, 3x minus 12 to the power of 2 that you need to calculate, right? So it will be 3x to the power of 2 minus 36x times 2. No. Yes, times 2, right? 72. And then the power of that, so plus 144 times 3, which is 3 to, do you have a calculator? Let's see. 3 times 144, 432. 432. Yeah? So, as you can see, doing this, we have a 3x to the power of 2, right? Which is also on the other side of the equation, right? So these two cross out, and then you have an equation to the power of, with the x to the power of 1 only. Yeah? So you will have one solution only, which is x equals 5.5. Yeah? Of course, if you have the statistical software or the statistical or Excel, 5.5 will be exactly this point here, right? So it will be the crossing point between the two. In the exam, if this is 7 and you find 5.5, I mean, it's of course okay. I mean, don't expect to find exactly the same value. Yeah. Okay. How can we test that this x equals 5.5 is correct? Well, at this point, we can plug 5.5 here and here, right? The sum of this and this should be equal, yeah? In particular, it will be 115.75, yeah? So if the left side and the right side of the equation have the same amount, 115.75, it means that you have found the optimal level of precaution, right? Because you are actually finding the same value for the two marginal functions. Okay. Okay, let's see if, yes, you see that here it might be 115. It's very close to 100.
Can we have 2x to optimal x?
Sorry?
Can we have 2 optimal x?
2?
Yeah.
Well, it depends on the two functions.
Economically.
Let's see. So it's in that case you should have two optimal global minimum of the total cost function, right? So if the total cost function is like this, you should have something like this or like this, yeah, with 3 minimum. Yeah, well, if you think about the fact that the total cost is function of the expected damage and the cost of precaution, it might be the case that the cost of precaution is not an exponential like this, yeah? So it might be that we have some economies of scale, and then you drop down, and so you have other costs adding up, yeah? And so in that way you can build up a total cost which has different minima, yeah? So it can be. Of course, at that point, the minima will be the same, yeah? If you find the same like value for x. It's different values of x for the same value of y. Okay? So yeah, of course, these functions are much more complicated if you take into account all the costs involved and all the possible damages involved, which are several probably, yeah? Okay. Okay, so okay, we have seen this already. We have equated this. Okay, any questions so far? Yes.
Here we're always operating under strict liability assumption.
Until point C.
How are we going to change
Now we change a bit the focus, yeah? We look at negligence. What does it mean? Negligence? You can tell me, what does it mean, negligence? What is the difference with strict liability?
The producer does not take responsibility.
Unless the level of precaution is too low. Yeah? So we have a critical value. If I put more precaution level than expected, I will pay only for the cost of the precaution. Otherwise, if I put too little effort in making sure that the victims are not affected, well, in that case, it's negligence.
Can you repeat that?
Yes. So the difference with strict liability is that with strict liability, you always need to pay the victims for the damages. For the negligence, instead, there is a critical level of precaution that you need to adopt. Yeah. So above that limit, if you put more precaution, you are not responsible for the damages. Yeah. Okay. Under that level, instead, you are responsible, and this is negligence. Yeah. So you need again to combine the two costs. Yeah. Of course, the total cost function in this case will change a lot. Yeah. So let's see what is the set of this negligence. Assume that the firm has to pay compensation only if the firm's level of precaution is lower than 4. Yeah. Now we can graph the total cost function and set out the algebraic definitions. Yeah. And indicate the optimal level of precaution. Here, in the exam, I would look at this indicate. Yeah? Indicate is different from compute. Okay? This means that the required level of maths is lower here. We indicate because probably from the graph we can understand already what is the level, the optimal level. Yeah? Let's see this. Yes?
So, because under strict liability, you always have to pay the expected damage. Why take precaution at all? It's more expensive.
Well, because, let me show you. Here you have a total cost, no? So in this case, if you don't take precaution, you spend 0 for the precaution, right? But the expected damages are so high that the total cost is very high. Yeah?
Because expected damage, because there's an inverse relationship.
Yes,
Okay.
exactly. Which makes sense, no? If I have I don't know, a container full of oil and I'm crossing the sea without a ship, for example, and without locks, the probability that everything will go out it's very high. Yeah. It's not very economically intelligent to do that, but yes.
So are the expected damages in this context always to a third party? Like, would it include damage to a firm's own machinery or something?
Well, here is not specifying that. The expected damage that you need to pay usually are set out by like a regulator. I cannot exclude completely that you are not taking into account the cost of damages on your own machineries. It can be. It's an interesting question. And if you are estimating the total cost, I would take that into account for sure. Okay. Point D. Okay, so our level, the limit for the negligence is 4, right? So it means that before 4, we are responsible for the damages. Yeah? So if X is smaller than 4, we still have to pay the 2, right? So the cost of precaution plus the damage. In this case, if X is bigger or equal to 4, then, well, if we go to trial, we demonstrate that the level of precaution was high enough, we just pay the cost of taking that precaution. Yeah? So we are not paying anything more. Okay? So in the trials, they are always trying to demonstrate that there was negligence. Yeah? Because of course the charge and the responsibilities are much different in that case. Okay. Okay. So how can we graph that? Well, until 4, it will be exactly the same total cost. Yeah. From 4 onwards, we'll take into account only the cost of precaution, which was increasing, right? So we will have something like this, and then it will fall and will increase according to the cost of precaution. Yeah. Let's see this with a more precise graph. As you can see, here we have the usual total cost until our threshold level, let's say. Then, from this point onwards, the total cost is only the cost of precaution, right? So you can see that if you need to minimize the total cost function, we already know what is the level. We can indicate without calculating. Yeah. Where is the minimum of this function? Of course, when x is equal to 4. Yeah. There is a shift. It's not a shift, but the total cost falls like to a very low level, probably below 100 or around 100, I would say. Yeah. Okay. So in this case, you can see that you already know what is the level. Yeah.
So just to be clear, in terms of the solution, the cost a company would pay is only ever going to be 4.
Sorry?
No. Never pay more than 4.
The level of precaution will be 4.
Yeah, optimum level as well.
Okay. Then at that point, we can plug the value 4 into the total cost function, and we see how much we will pay.
Sorry. Okay. Yeah.
Okay. This is actually point D, because here you can see that it's jumping down, right?
Yeah.
So it's interesting to see what is the difference here.
So it's going to be 100-ish.
Yes, and this one will be more than 500, almost 600 probably. Okay.
I'm just mentally a bit hung up. Why does the curve, the proportion curve, continue? Why does the total cost curve continue to go up after 4? Because 4 is kind of an asymptote, isn't it? It's a flat line to 4.
Okay, in 4, we are not responsible anymore.
Yeah.
But we can still increase our precaution, right? If we increase the precaution more than that, we'll pay for the fact that we put more precaution.
Okay. It's what you can do rather than the optimal.
Yes,
Right.
yes. Maybe you want to send a marketing signal to the consumers. We care about you, so we have doubled the level of precaution, and we are in it. Yeah?
Yeah.
Of course, there will be a higher cost. Yes?
How do we know that it's continuous at the core?
This part here,
Yeah.
well, we have like two values of y for one values of x. Yeah? So there is a discontinuity there.
Yeah. So this, I mean, there it looks to be continuous.
Yes.
Yeah. So I mean, when it's less than 4, it's the line that goes up, and when it's equal and more, it goes up on top. So why is part of the line that shows that for x equals to 4? It's something
Yes.
between 100 and 600, doesn't it?
Yes, yes.
So it's, I mean, it's
Basically,
100 or
you would
600?
you would like do
Oh.
this with dots, right?
Oh, cool. So
I
it's
think that
discontinuous.
mathematically is more elegant.
Oh, so it's discontinuous at this point.
Yes, because you have multiple levels of cost for 4, right? You have the two extremes also, yeah, right? So in this case, we are still in the previous curve, and here we are in the next curve, right? Okay. Now let's focus on what we were discussing a few seconds ago. Where is it? Ah, yes. What is happening? Okay. 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 I understand. Compute the total cost for the firm when it adopts a level of precaution equal to 4 under strict liability and under strict negligence. So here we need to compute, yeah, but we are just looking at the two extreme points, yeah, at 4, where the function is falling down, yeah, here. Okay, so in this case, we put a 4 in this total cost. Yeah, the total cost that takes into account both the components. And we find this point here, right? In the second case, we plug 4 into this simple total cost number 2. Yeah, because we are only looking at the negligence case. Yeah. We will intercept, we will find out the level of y here. Yeah. So, as you can see, instead of all the x's, here we have nice 4, 4, 4, 4, 4, 4. We have almost 600 for the total cost, and a bit more than 100 in the second cost. Yeah. So we were more or less right in terms of the level of y in this case. Yeah. Okay. Yes.
So, in this case, when x equals 4 in real life, it would depend on the scale of the lawyer. That you have to pay 1, 1, 2, 1.
Well, actually, yeah, it depends. It depends on how the regulation is set up.
That's my
In our case, in the problem set, we are saying that for levels which are lower than 4, we need to pay. So the responsibility of the lawyer and the rest of the team of the company is to demonstrate that your level of precaution is actually 4 and not 3.98. Because probably you will go for 4 because you want to minimize the total cost. Yeah? And so the defense of the people will try to do the opposite, right? They will try to demonstrate that you have put less than 4. Okay.
I also want to ask, in the real situations, do courts operate under negligence or strict liability, or it depends?
Usually, you are still responsible if you do like a huge economic, environmental damage, for example. Of course, you are responsible, but the measure in which you are responsible depends a lot on the level of precaution. Yeah. So, for example, if you didn't put the level of precaution as expected or as the regulator set out, because probably it's mandatory, in that case you have penal charges. Yeah? So we expect lots of people go to jail at that point, and the penalty will be billions. Yeah. And yeah, in the other case, probably you can try to limit in some way the amount that you need to pay. Okay. So it's quite unrealistic that because of the fact that you put a great amount of, like, great level of precaution, you will not pay anything about the damages. It's quite unlikely because it's not socially acceptable. Of course, here we are in a hypothetical set, yeah. And what is the what is the consequence of what we are saying now? That probably this total cost function will shift up, yeah, because probably you still need to pay something at some point to someone if something goes wrong. Yeah? So all the total costs for each level of precaution will be a shift, or it will be a shift not regular, right? So some parts will shift in a different way. Yeah? Okay. In general, the expected damages function will be a bit different from the one that we have here. So, yeah.
Do you mean that even with negligence, your total cost will shift up?
That probably like even if you are putting the level of precaution which is above the level of negligence, you will still pay something. Okay. Yeah. But of course, you cannot take this into account in this problem set, because otherwise you need to take a percentage of the expected damage function, maybe. Yeah. Okay. Okay. So just to recap very briefly, we have liability. It can be strict, or we can focus on the negligence. Yeah. We have the firm that has a cost of the precaution and the cost for the expected damage. Yeah. The firm will try to estimate the total cost, yeah, considering the two functions, and minimize the thing. Minimizing the total cost function, or equating the negative marginal damage with the marginal cost. Yeah? In that level, you find the optimal level of precaution. Yeah? If you have negligence, of course, in the part which is above the threshold, all the expected damages in these problem sets are completely excluded. Yeah? Which makes sense considering the definition of negligence. Yeah? Okay? That's all. Any questions?
Are we allowed calculators in the exam?
Sorry?
Are we allowed calculators in the exam?
You have a calculator, and there are strict rules about which calculator you need to take.
Okay.
Oh, so we bring one.
Sorry?
We bring one.
You can bring your calculator, but you need to buy the one that is accepted by UCL, which is a Casio or something. And of course, they are selling it in the central, the main course. So. But it's a nice calculator. I still have it. It's like working great. I never changed the battery. So.
Can I ask
Probably I've never used it any after the exam. But yes.
Can I ask something quite silly?
Of course.
But aren't you allowed to use colors and erasers and not erasers like blanco?
Yes, I think so. You cannot cancel with the blanket, I think.
Oh.
But you can use colors.
Okay.
If you have done something wrong, you need just to cross, to put like a cross like this, and write somewhere else. Okay. So the advice that they gave us was that of course the cleanest, they expect you to write in a most tidy way. So the cleanest is your work, the better is, both for you because maybe the marking is easier and it's clearer for us to understand what you meant and which is the right result, etc., etc. And in general, it's just like a policy that they are using here. Okay. So tomorrow we will have the other one. If you have time, you can have a look on Moodle. It's already there with the solutions. Otherwise, we see it together tomorrow. Okay.
Just a quick question. Going through the past papers, the questions appear to be quite different to these problem sets. There's not so much. I was happily surprised. There's a lot less math than I was expecting. Are you trying to give us a heads up that this year's going to be more mathematical, or?
The problem sets are more or less, I mean, I've added something this year, but the level of maths, like in the requirements in the problem sets, are the same. So every year you add more or less this kind of problem sets.
Okay.
So this means that if you want to take this as a hint that probably the exams are less mathematical,
okay,
it might be.
I'll rephrase it another way. If I'm comfortable with the questions of previous years, then can I expect that I'm on the right lines for this year?
It's unlikely that the level of math will be completely different. I would try to be completely confident with the problem set level.
Okay.
Just because maybe it's not mathematical, but then there is one question which is with the partial derivatives, etc., and if you are very fast in that one, you have more time for maybe the Polykin's part, for example.
That's what May is for.
The
month of May.
I imagine. Okay. Okay. So after tomorrow, and then I let you go already. After tomorrow, I will put like a doodle or something like that on Moodle with all the problem sets, and you can vote the most complicated one. Yeah.
Okay.
We will have 2 hours, so maybe we can do 2 or 3 problem sets. Yeah.
In May.
In May, it will be like 15th of May, something like that. Okay. So in that period, it's just this exam. So yeah. Okay. Okay. So I see you tomorrow. No worries.